All right, so 5-2 day 2, we are going to be reviewing some of those strategies we talked about yesterday. Okay, so when you are solving by factoring, you want to get all of your terms to one side, and we're going to make sure that that is equal to 0. Now, when they tell you to solve by factoring, that means you have to factor the polynomial completely, and you have to look out for those GCFs, so that greatest common factor. So when you're factoring the polynomial completely, make sure you take out the GCF, and you look for those special patterns. We saw yesterday that a lot of times you're going to have that difference of 2 squares that you're going to have to break down. Okay, so we're going to solve by factoring. We have 4x to the 6th plus 4x to the 5th minus 24x to the 4th equals 0. Okay, so we're going to solve each polynomial equation by factoring. So we definitely got to watch out for the GCF or special patterns. So the first thing we want to do is see if there is a GCF. So as we look at this polynomial, is there anything we can take out?
4x.
Yeah, 4x to the 4th. Okay, so then we're just dividing. So we would be left with x squared plus x minus 6. Okay, and then we have a trinomial here, so we're going to try to factor that as well. When you're trying to factor the trinomial, remember the GCF just stays in front. We can split it up into x and x, multiplies to a negative, which means you have opposite signs. And what multiplies to 6 but adds to 1? 3 is positive, 2 is negative. Great. Now your last step is to set all of the factors equal to 0 and solve. So if you have 4x to the 4th equals 0, you have x plus 3 equals 0, and x minus 2 equals 0. Remember, this is because if you know the product is 0, one of these has to be 0. Okay, so for these two, we know it's just x is negative 3, x is positive 2. But for this one, we are going to have to solve. So we're going to divide both sides by 4. And then how do you get rid of a 4th power? How do you undo that? Take the 4th root. Yep. So not the square root, but the 4th root. Do you guys know what the 4th root of 0 is?
0.
Yep. And then usually with roots, we do the plus or minus, but because 0 is not positive or negative, you don't have to worry about it. So your zeros are your solutions. Those are your roots. So it's 0, negative 3, and 2. All right, so for B, I want you guys to see if you can factor this. So we want to move all the terms to one side. Okay, and then after you move all the terms to one side, you have x to the 4th. So how are we going to start our 2 parentheses? How are we going to start each of them? Yeah, x squared and x squared. Good. So x squared times x squared would be x to the 4th. And that way when you combine your like terms, you'll have the x squared there. Now if it's a positive and then a negative, they're both going to be negative. What multiplies to 25? That adds to negative 26. 25 is 1. And then remember, you have to look out for those special patterns. So we have the difference of squares here. This is going to factor into x plus 5 times x minus 5. This will factor into x plus 1 times x minus 1. Okay, and because those are all multiplied together, we know that one of these has to be equal to 0. Okay, now I feel like I mentioned this once before, that there's a relationship between the number of zeros and the polynomial. You guys remember me telling you anything about that?
X from like the degree is the highest number of zeros.
Yeah. Did you guys remember that? That the degree is the number of zeros that you should have? I mentioned it, but I don't think we talked about it a lot. We will talk about it more later on. So if the highest exponent is 4, you should have 4 zeros. With this one, the highest exponent is 6. You only see 3 zeros here, but someday we're going to talk about multiplicities. If you take a 4th root of 0, this means that there's a multiplicity here, so this actually counts 4 times. So these would be 4 of the zeros, this would be 5 and 6. Okay, so that only happens if you take the 4th root of 0. You're going to see with a lot of these that the solutions are going to be going to be equal to the number of your degree of the polynomial. Okay, and then for part C, we have x cubed minus 2x squared minus 25x is equal to negative 50. Okay, and remember also that zeros are solutions. Those are roots. Those are your x-intercepts. Okay, they are all of those things. So once you move the 50 over, we have 4 terms. And yesterday we learned that if we have 4 terms, how are we going to factor this? Grouping, yep. So we're going to group the first 2. We're going to group the second 2. We're going to find what they have in common. So x cubed minus 2x squared, what can I take out? Yep, x squared, good. So then I'll have x minus 2 left inside. Now we want the same thing left inside here. So we're going to take out negative 25 so that we get that x minus 2. And then yesterday we also talked about why this works, where you have the x squared minus 25, okay, times x minus 2. We're just rewriting that with the distributive property. Okay, so basically what you're doing there is, if you had x squared y minus 25y, you wouldn't leave it like that, right? What would go in both of them? What would you have to take out? The y. Okay, and then you'd have the x squared minus 25. That's what we're doing, except it's not y, it's x minus 2. Okay, so what we're pulling out is that x minus 2. We just wrote it in the other way, x squared minus 25 plus x minus 2. Okay, now because we're factoring completely, we want to make sure we recognize that difference of 2 squares can be broken down into x plus 5 and x minus 5. Okay, so when I'm reading this on a quiz, when it says, oh, you have to solve by factoring, I'm looking for this step in particular, okay, and giving you like a point for being able to get there. And then we're going to have to solve, so we know x plus 5 is 0, x minus 5 equal to 0, x minus 2 equals 0. So x is negative 5, x is 5, x is 2. So again, the number of zeros is equivalent to the what? Degree. So you can see you have 3 and we did have x cubed, so that is great. All right, any questions for me? All right, then we are going to solve polynomial equations. So they're still going to be factoring in your polynomial equations. Okay, and then I just want you to keep in mind that the number of solutions that you're going to have is going to be equal to the degree. That's a great way to make sure that you have found all of your solutions. Okay, so we have x to the 4th minus 3x squared minus 10 equals 0. Okay, so I want you to start your factoring. You look for the GCF, special pattern, guess and check. Okay, and then once you factor, you can set each factor equal to 0. So it's x to the 4th. So how do we start each parenthesis? X squared and x squared. Notice that it does match the middle. Anytime you have a negative, you should have opposite signs. So what adds to -3 but multiplies to -10? So you have to have a +2, a -5. Say it again. Only if you had it in this one, so it has to be in all of them. Because it's not in the 10, you cannot factor that out. So you can only factor out the GCF if it's in all of the terms, or if you're factoring by grouping. Okay, and then when you're solving here, this is what I want to see. So you have x squared is equal to -2. Here you have x squared is equal to 5. Okay, and then to get your final answer, you have to do your square root. So you're taking the square root, and anytime you have a square root, you have to have the plus or minus in front. If you have a negative, what else do you have to have? So it'll be plus or minus I root 2. So this is 2 of your zeros. And then here we take the square root, and x is plus or minus root 5. Are there any perfect squares in root 5? Nope. So then you're going to keep it just like that. Okay, and I do need to see this step here. So you have to do your square root of both sides. Okay, I want to see how you're solving. All right, now when we're solving, your solutions are going to have certain forms, so we're going to write those here. So all of your solutions need to be exact. And simplified. All of your solutions need to be exact and simplified, okay, or in simplest form. So if it's exact, that means it is not rounded, and so we will leave radicals in there, okay, but that comes with some other rules. So when you're simplifying, if you have a fraction, you have to make sure you reduce all the fractions. If you have a radical, you have to simplify the radical by taking out the perfect squares. And then one that we haven't done in a while is we are going to have to make sure that we rationalize the denominator. Do you guys remember when we do that? In what situation? When you rationalize the denominator. when the radical's on the bottom. Yep, so when you have the square root on the bottom, we are going to have to rationalize that. Okay, so keeping those rules in mind, I want you guys to do part B. So you have 9x to the 4th minus 27x squared plus 20 equals 0. Okay, and like 9 goes into both of these, but it doesn't go into 20. You don't have any variables in all of them. So when you're doing the guess and check portion of this, remember that you have two options. You can either start with 9x squared and x squared, because that multiplies to 9x to the 4th, or you can do 3x squared and 3x squared. Okay, so, and then they have to multiply to 20. So I'm going to give you some time right now to do the guess and check, and then I want you to solve as much as you can. Guess and check in, and find what multiplies to 20, and then a positive 20, and then adds to negative 27. So check with FOIL so you find it. Okay, so what worked? The 3x squared and 3x squared, or the 9x squared and x squared? The 3's worked, okay, good job. And then because this is positive and this is negative, they should both be minus. So make sure that you set that up so you know when you're plugging them in that you're going to be adding them together. Okay, and then if you need to, remember, you can always do your T-chart. This is going to give you your choices, because there is a limited number of choices that you have here, right? So 1 and 20, 2 and 10, 4 and 5. What is the lucky combination? 4 and 5. Yep. So if we check, it's negative 12 minus 15. That's how you get the negative 27. So what we're going to do is we're going to set each one equal to 0. Okay, and you guys did a nice job of moving that over and then dividing and taking the square root. Okay, and then when we got here and you had to take the square root, let's remember what we got. So when you take the square root, you have to have the what? plus or minus, yeah.
2a.
And then when you have a square root of a fraction, remember you can split it up into the square root of the top over the square root of the bottom, which is helpful because the square root of 4 is 2. Now we have to rationalize. Who remembers how to rationalize? Okay, what do you multiply by?
Multiply both sides by.
Yep, so multiply the top and the bottom by root 3. The reason why you can do this is because you're multiplying by 1. If you multiply by 1, you don't change the value at all. The reason why we want to do that is so we don't have a radical in the denominator. So root 3 times root 3 is equivalent to the square root of 9, and the square root of 9 is 3. And then the top is just 2 root 3. Because this is outside of the radical, it stays there. Okay, so this is going to be 2 of our answers. And then here, you can multiply this by root 3 over root 3. And now, when you have a radical times a radical, that's just the square root of 15 on top. The denominator is still 3. Be careful at this step because we see the 15 and 3 and we know that they go so nicely together and we want to simplify, but we cannot because 15 is stuck inside that radical. A radical is a grouping symbol. It acts as parentheses. So before you can divide by 3, you'd have to take the square root. So you cannot do 15 divided by 3. Okay? Because it doesn't follow your order of operations rules. Okay. All right, so those are your 4 answers because you have a degree of 4. All right, now something else from yesterday is coming back. We have x cubed plus 216. Okay, so yesterday we learned about special patterns, right? This is the sum of 2 cubes. So we ask ourselves what to the third power is x cubed and what to the third power is 216. Okay, we know that x, some of us still might not be fully comfortable with what the cubes are yet. So I always say start with something that you do know to the third power. So I feel like we should all know 5 to the third is 125. So then I would try 6. So all you have to do is multiply. 6 times 6 is 36. 36 times 6, 216. Okay, so then when you are using your pattern, your A value is the x, your B value is the 6. Okay, how are we doing at that pattern after yesterday? Okay, so anytime it's plus, remember you start with the plus, and then you square it, do the product, and then square it. Okay, square, product, square. And these two should be opposite. All right, so then if we're finding our zeros, remember we still have a product. This times this is equal to 0. So either x plus 6 is 0 or x squared minus 6x plus 36 equals 0. So this one we know right away is going to produce negative 6. Remember yesterday what I told you about this trinomial? Because normally with a trinomial we try to factor it, right? But this is not factorable. That's still true. This is not factorable. Okay, but we know what type of equation this is. What type of equation is it? That you do have a perfect square in it. It's not a perfect square trinomial because it's not factorable. It's a quadratic equation. How do we solve quadratic equations without calculators? Yep, quadratic formula, good. Or what? Do you guys remember one of the other methods we use? We are going to use the quadratic formula. Yeah, quadratic formula is great. You guys don't remember the other way? Completing the square. Okay, I'm just saying you got options. Okay, so we have the opposite of b, plus or minus b squared minus 4ac over 2a. You have your a value is equal to what? What's our A value there? 1. B, -6, and C, good. All right, so I want you guys to plug that in, and I want you to simplify. Okay, so we're doing the opposite of B. I always do B squared first. So -6 squared is 36. And then I like to write this step out so I can see whether I'm going to be adding or subtracting. Okay, so I have 36 minus 4 times 36. So remember all the mental math strategies we've been talking about this year, right? You can multiply 4 times 36 by doing 4 times what?
30.
Yeah, which is 120. So 4 times 30 is 120. 4 times 6 is 24. Okay, so underneath the radical, you have 36 minus 144. Okay, it's a lot easier to do 144 minus 36 and then just change it into a negative, right? Okay, so if you subtracted 36 from 44, do you guys know what that is?
What?
If you did 44 minus 36,
That's 108.
it's 8. And so, yeah, because it's the 100, it'll be 108. Okay, and then because this is negative, it's going to end up being a negative. So you have 6 plus or minus the square root of negative 108 divided by 2. Another way that you could do this is you could think about it as if you have 36 minus 4 times 36, you can think of it like this. Isn't this 1 times 36? What's 1 minus 4? 3. So it's just negative 3 times 36. You could do it that way as well. It doesn't matter. It just means you only have to multiply once and you don't have to do the subtraction. Because 3 times 30 is 90. 6 times 3 is 18. And again, you get the negative 108. Okay, so that's just another way to think about it. All right, so we remember that negatives mean we have to include our I value. And then we have to make sure that there's no perfect squares in 108. So I'm going to go through the factor tree again with you. If you are a factor tree mastermind, you can go ahead and do that without me. So for 108, you're going to cut it in half. Yes, so the goal is to get the prime factors. So 2, 3, 5, 7. Okay, so we always start with 2 or 3. So 2 goes in there. And then we can cut it in half. 2 goes into, I know I said if you could, I want you to do it on your paper. I'm going to help the people who need it. Okay, and then for 27, 2 doesn't go into 27, so we're going to, okay, and then here you're going to split it up into 3 and 3. Now the rule with the prime factorization is if there's a pair, it comes out of the radical. So it has to have a friend with it. That's because really what you're doing here is the square root of 4. And the square root of 4 is, square root of 4 is 2. So that's why it can come out. Okay, and then 3 and 3 is the square root of 9. So that's going to be 3. That can go outside. Now this is what's left over. So you had a 2, a 2, a 3, a 3, and a 3. This came outside, this came outside, the 3 stays inside. Okay, so what you have is 6 root 3. So if you have I times 6 root 3, you're going to have 6 plus or minus 6i root 3. And then the divided by 2, we're going to divide each of these by 2. Now you can simplify this here. So 6 divided by 2 is 3. And then you can simplify what's on the outside. Okay, and again, you have 2 of your solutions here. The 3 plus or minus 3i root 3. Here you have your third solution, and you have x cubed. so there's a lot of stuff coming back from earlier sections. How are we doing? We have the imaginary numbers, we have the simplifying radicals. All right, so then let's try part D. Let me do this part with this first. Okay, so now we have x to the 6th plus 7x cubed minus 8 equals 0. All right, so whenever we had x to the 4th, we split it up x squared and x squared. Now that we have x to the 6th, we're going to split it up. X cubed and x cubed. And again, you can look at this middle term here, right? See how that's x cubed? Okay, because some of you might have been thinking, well, why can't I do 4 and 2? Because that multiplies to x to the 6th. You're absolutely right. So the key is you want these to be the same so that they add up to that middle. So we want something that multiplies to -8 but adds to +7. So we need a positive and a negative. Plus 8 minus 1. Okay, now you cannot just set these equal to 0 and solve. If you do, you'll be missing some of your answers, okay? That would only give you your real number answers because it's a cube root here. So you have to use your special patterns. Remember, our special patterns are the sum of two cubes. They're the sum of cubes. And we have to use the difference of cubes. All right, so based on what we did yesterday, I want you guys to write out these patterns. And they are equal to 0, so we'll talk about that. Okay, so will you write those out, and then you can think about how we're going to solve them, and then do it. Yeah, All right, so when you're filling this out, remember your A and your B value are what makes those perfect cubes. So 2 to the 3rd is what makes 8. X to the 3rd is what makes x cubed. So this should be x plus 2. First sign always matches. And then we do the square, the product, the square. The last symbol is always plus. This is always the opposite of the first symbol. Okay? For the difference of cubes, your A value was x again, but what was your B? 1. Okay, so if it's the difference, x minus 1, again, you square it. You do the product, which is 1x or x. 1 squared. This is always plus. This is the opposite. There you go. When we're solving, your first factor is very simply solved because it is a linear binomial. But here we have two quadratic trinomials, and we must use the quadratic formula. Fortunately, we must use the quadratic. All right, so if you haven't already, I want you to plug those in and simplify. So simplifying is usually the most challenging part of it. All right, how do you think we did? All right, so we have x equals the opposite of b plus or minus b squared minus 4ac. So when you're doing that, notice I simplify that part, I leave this so I can see what I'm multiplying and what I'm subtracting. So I have 4 minus 16, which is going to give me negative 12. Okay, and then with 12, a lot of you are going to know what the perfect square is. What's the biggest perfect square in 12?
3.
And which one's the perfect square? 4. Yep. Okay, so then this becomes 2 plus or minus 2i root 3. You divide both by 2. So if you divide 2 by 2, you get 1. And then here, those 2's cancel, so then you have I root 3. It is common to keep the I in front of the radical so we don't accidentally put it behind it, like inside the radical, so we can leave our answer like that. And then for the second one, you had all 1s. So it's the opposite of b plus or minus 1 squared is 1 minus 4ac divided by 2a. So 1 minus 4 is negative 3. We know we have to bring out the I. So I root 3, each one divided by 2. You can either write your final answer like this with the I in front, or you can write your final answer with the I on the side. But those are the only 2 forms your final answer should be in. Some people like move the negative 3 to the side. Don't do that. Then you're like on multiplying it. Okay, so root 3 over 2i, or you can write the I in front of root 3. Okay? How do you do with their simplifying? So, okay. All right, so I'm going to give you time to work on your homework.